Well, hello everybody, welcome back. Tonight we are going again, doing what we were doing last time. Hopefully not get as lost as we were in the sea, the cloud of confusion. Well, we didn't know what the fuck was going on. Turn that down a bit. And there we go. Hello everybody. My camera angle change again? What is happening? Hold on. No, that's right. I swear this camera changes every single time I do this. I don't know what's going on with it. I'll just keep it as is. Who cares? Who cares? There we go. Can I get a visual of everything again? I swear this changed. No, it didn't. Okay. I don't think so. Maybe. Who knows? Who cares? We're continuing what we were doing last night, which was scratching our heads because we're confused as to what the hell is going on. Yeah, these are old tutorials too, so may not be the absolute best of the best when it comes to stuff like this. Well, I'm opening my Steam up. Give me a second. Completely forgot to open that up.
Welcome, type.
Hold on. Just open this shit. There we go. All right, now open this up. And bam. There we go. We back into it. So, last time we were cooking with this. But this was about it. We're more specifically, hold on. We're cooking with this. And a lot of information went over my head.
It as a child of a Node 3D, which will act as our pivot. If we don't have one and try to rotate the camera, we get some very janky results. If you're curious as to why this happens, I will link to a page in the Godot documentation that explains it really well and also has a code snippet that would let us do it without a pivot. Now if we start up our game, we are able to move around and even jump out of the box, but we can't look around just yet. So let's get cracking on our code. We have the speed and jump velocity constants here. The gravity variable is taken from the default project
That was
settings,
not there
which is
at all.
9.8. Screw that, it's now 9.8. In the physics process, we handle our jump. When the player presses space, we set the velocity so we're going up, and then every tick we lower this velocity if we are not on the floor until the velocity is in the negatives and we are going down. At the end of each tick, the move and slide function is called, which moves around our character depending on this velocity vector and then changes the velocity depending on collisions. So when we're about to land, our y velocity is negative 4.5, and then bam, it's 0. And it stays at 0 because we are now on the floor and are no longer changing it. This last code block takes care of movement on the floor. It tells us that we should replace the default UI actions with our own, which we will do in a second. Here we get a vector 2 movement vector from the inputs and change it to a vector 3 so we can multiply by where our character is facing, which gives us this movement direction vector. If it's non-zero, which means that we pressed a button, we set the velocity components by multiplying the direction vector by our speed. This next part has a bit of a mistake in it. The intention here was to add friction and slow the player down gradually, but as this thread on the Godot GitHub suggests, it just sets the velocity to 0 instantaneously. So let's make that clear in the code. The next step is adding our own input map. We can do this by going into the project settings, naming all of the actions that we want to use in our game, and setting bindings for them. We add our new actions to the code and then see what we need to do. We can see our cursor so it's not captured.
Wait a second, hold on, I'm on the wrong project, my bad. Who's this one? Okay. Excuse me. Yeah, there we go. Much better. Um. Uh. Okay. So. What? Wait, I clicked the wrong thing. My bad.
Can't look around. So the first step then
So this character. Uh. Do this right, so that equals. Okay. What happened? What? What the fuck? Why the fuck? Why is my spacebar hitting the end key? What? Oh, that's gonna annoy the hell out of me. Guess we're dealing with this for right now. Fuck. There we go.
then is to get rid of the cursor. We can do that in a ready function which
Uh.
runs at the beginning
Oh, it's set mouse.
of a scene by setting the mouse mode to captured. After that, let's define variables for the head.
What?
And the camera so we can access them easily in the let's define variables for the head and the camera.
Hold on. What the fuck?
Setting the mouse mode to
Oh. Oh yeah, honestly, I think we should just move on to the next one because this is that day and I can't even do the script right because I don't know. I'm kind of like stuck right now.
Welcome back to the channel. Today we'll be doing a Godot level design tutorial and building this map from the ground up for a game that I'm working on that's similar to Call of Duty Zombies. We'll be starting off with only a character controller that I made for a different video, and I hope to have something here for everyone. And dragging it to the texture setting in the albedo section. Right now the texture is stretched to fit the entire box, so let's turn on the triplanar setting in UV1 so it's repeating instead. That's our ground done, and it's time to start laying the map out with some models. For this map, we'll be using the Graveyard Kit from Kenny Assets that he's kind enough to provide for free for everyone to use.
This is simple enough. I'm sorry, I'm just skipping ahead to see to do here. Oh, I guess this could be a good way. It doesn't seem any
Welcome
code
back to
really.
the channel. Today we'll be doing
This is another
a
2 year
Godot
ago
level
one, so I was
design.
worried about the code, but it seems like I could just go through this without having to worry about that. It gives me an idea as to how I can stuff like that up. Game level. I need to figure out what the hell's going on with my keyboard. 1 second. Good lord. I'm sorry, I keep coughing. Hold that muted my mic. That muted my mic, right? Yeah, it looks like it should have. It was empty. I thought I popped up for a bottle that had stuff in it. Projects. Little tutorial. Oh. Yeah. Texture. Graveyard, okay. And it was AI. Hell no, I'm not doing that. No, that was the way that man looked at me. I'm not going anywhere near that product. Okay, let's just... How about this? What? Maybe. What was it? Body. That no. Let's see. If there's a way I could steal the image out from underneath this. I'm not fucking logging into this shit. We're just looking up dirt. We're gonna go look up dirt. Ignore this. Alright. Oh. Dirt. Texture. Game. I don't know. Or this is kind of like what they are working with. No, I don't want to join your shitty fucking website. Oh, I gotta find a workaround for this. You'll be part of the thing. New folder. Bet your ass I'm not signing up for another fucking thing. That's only I'm only ever gonna use once in my entire fucking life. I'm sorry if anyone else is going to donate to this man immediately.
Design tutorial and building this map from the ground up for a game that I'm working on that's similar to Call of Duty Zombies. We'll be starting off with only a character controller that I made for a different video, and I hope to have something here for everyone. I'll try to make it as beginner friendly as possible, so tag along for the ride. So we're starting off with a simple scene with just a player and a CSG box for the ground. As the first step, let's increase the map size to 100 by 100 and then find a ground.
We're gonna go and say bam. So it was like 100 by 100. And then 0.02, I think it was. Something. It was some very small number. I said it's fine.
Ground texture for our game. After some googling, I found this nice cartoon texture, and plugging it in is only a matter of creating a new material for our ground CSG.
Assets, ground soil. Hell yeah. Look at that ground. As far as the eye can see, it's ground. Amazing. What's the fucking thing they had us do? Is this UV1 right planar? Oh yeah, that's way better. I mean, it's probably actually zoom out, you can see, but that does exactly what I needed to do. Let's add $30. Oh, to you. Okay. PSG box. You know what? Make it a sphere. Got you. Then I need a collision. Which, you know, obviously gonna make that shit another sphere. Perfect. I need to add that's running settings, input map, up, like forward, backward, left, right. Okay. Okay. Okay, so we're gonna add a node. Attach a camera to it. Damn it. Let's tip toe on the bot. Round. Just say visual. All right, now what happens if I do this? Hell yeah. It's so goofy looking. I love it. Always say on. I realized that I could just do this, I think, because we're doing a first person, aren't we? Well, I suppose it doesn't really matter all that much. So let's do main. Fuck. Try to get the crown some collision. There we go. Oh, yeah, that's right. It's only arrow keys. The arrow keys exclusive right now. I need to like give you like actual things. Oh yeah, I love this barren desert, fucking wasteland ass location. Curious about something. Okay. Back up. Yeah, no ball, so I assume I end the ball still. What was the way they did the camera movement? Mouse. Input event mouse. Dots. How did we do this earlier? Project list. Remember how we did this? That's right, it's over here. We're good. No, it was all done on the camera or on the player scene. Mouse mode. So that's how they did it. Okay. Input.mouse mode equals input.mouse mode captured. Okay. It was input mode is equal to, there we go. And then there was one that was like function input event if input the input event is motion pass. Oh, that if event. There we go. Then what was it? Mouse. Go back to it. I don't remember what we did. Oh, it's just rotating the camera. Also camera mount. Where's camera mount at? Okay. So what I gotta do here. Uh, so camera mode R to X. Mouse. Yeah, I can remember this. Why? Okay. So I don't remember how exactly we did this. This is making sense, but I forgot I just kind of read off his tutorial. Okay, data rad event dot realize or relative x and relative y. Do. Okay, what opens here? Let's try this out instead. What? Sick. Well, shit. Maybe I should go watch the first video.
Hello and welcome back to the channel. To rotate the camera, we get some very janky results. If you're curious as to why this happens, I will link to a page in the Godot documentation that explains it really well and also has a code snippet that would let us do it without a pivot. Now if we start up our game, we are able to move around and even jump out of the box, but we can't look around just yet. So let's get cracking on our code. We have the speed and jump velocity constants here. The gravity variable is taken from the default project settings, which is 9.8.
Okay.
Screw that, it's now 9.8. In the physics process, we handle our jump. When the player presses space, we set the velocity so we're going up, and then every tick we lower this velocity if we are not on the floor until the velocity is in the negatives and we are going down. At the end of each tick, the move and slide function is called, which moves around our character depending on this velocity vector and then changes the velocity depending on collisions.
Amazing.
So when we're about to land, our y velocity is negative 4.5, and then bam, it's 0. And it stays at 0 because we are now on the floor and are no longer changing it. This last code block takes care of movement on the floor. It tells us that we should replace the default UI actions with our own, which we will do in a second. Here we get a vector2 movement vector from the inputs and change it to a vector3 so we can multiply by where our character is facing, which gives us this movement direction vector. If it's non-zero, which means that we pressed a button, we set the velocity components by multiplying the direction vector by our speed. This next part has a bit of a mistake in it. The intention here was to add friction and slow the player down gradually, but as this thread on the Godot GitHub suggests, it just sets the velocity to 0 instantaneously. So let's make that clear in the code. The next step is adding our own input map. We can do this by going into the project settings, naming all of the actions that we want to use in our game, and setting bindings for them. We add our new actions to the code and then see what we need to do. We can see our cursor, so it's not captured, and we can't look around. So the first step then is to get rid of the cursor. We can do that in a ready function, which runs at the beginning of a scene by setting the mouse mode to captured. After that, let's define variables for the head and the camera so we can access them easily in the code. References to nodes have to be saved in onReady variables, and if we want to get the path to them, we can just drag them from the scene tree. Next, to actually rotate the camera, we use the unhandled input function, which is called every time a player does anything, like press a button or move the mouse. We are looking
Okay. Okay, so It doesn't have a ready function. I thought I put a ready function in here. Guess I didn't. Dots. Mouse mode. Equal to. There you go.
Specifically for mouse motion.
Forward. Backward.
Events, so we check if it's of this type. We change the rotation of the head depending on how much the mouse moved relatively, multiplied by the sensitivity, which we're going to add as a constant. Here we're keeping the rotation axes separate, so we're only rotating the head on the y-axis and the
Okay, so unhandled input event. If event is event mouse motion, dot date. I'll leave both of those in here. Dot rotates Y. Event dot tab times come on, there we go. Camera dot rotate X event relative Y. I fucking did these around the wrong way. Oh, I just want to go down. Fuck's sake. There we go. Dot Y. times. What did I just do? There we go. Times 30. Oh, she could see this. There we go. Yay. Way too fast. I just had this on a blank screen this entire time. Hold on. Over here. Fuck. My bad. Okay, that's not good. Yeah, F9 undoes your mouse.
Camera on the x-axis to avoid the whole rotation order mess. You'll also notice we're rotating the head Y angle depending on relative X distance. This is not a mistake, but rather just a byproduct of how translating mouse movement to camera rotation works. When we move the mouse left and right, we want to rotate around the Y axis, which is pointing up, and when we move the mouse up and down, we want to rotate around the X axis, which is pointing to the side. So after putting all of this together, we can finally look around. Our sensitivity might be a little too high, and also we can do cartwheels with our head. So let's use the clamp function, which can limit the rotation of our camera to a minimum and a maximum value. I'm also getting...
Oh, okay. Camera dot. Is equal to clamp. Oh, it's not rotate, my bad. Okay, then
getting tired of staring at a whiteboard with nothing on it, so let's use a bunch more CSG boxes with different color materials to create a map. Much better. The last thing we need to fix with the basic movement is the fact that we're not really moving in the direction that we're facing. This is an easy...
Why is this not doing anything? What the fuck is happening? Yeah. I got these wrong. Maybe this should be Y. This the other one should be X. Fuck. God damn it. I just want to fucking get out of that. Oh, that's so much better? Question? No. Still several things wrong. Get me out of this fucking thing.
Nothing on around. Our sense clamp function, which can limit the rotation of our camera to a minimum and a maximum value. I'm also getting tired of staring at a whiteboard with nothing on it,
So usually just turn this way down. Did I miss something? Going up and down is maybe left and right. Right and left is making me go up and down. What? Okay. Okay. Why is this backwards though? Because this is using X, but it's here it's Y. It's relative to Y. But not the other way around. Also, why do I then? Okay, no, that was working. I just need to actually add the mice. I don't know why I thought it was the other way around. Okay. I need to fix that clamp. That is driving me up the wall. 90. Paint controls. Oh yeah. Also, kind of quite trippy. There's that.
So let's use a bunch more CSG boxes with different color materials to create a map. Much better.
The last thing we need to fix with the basic movement is the fact that we're not
Actually, no, I'll do something like that. Uh. Vision. Uh. What the fuck? Gonna put like something sort of like black colored thing in there. That'd be like a little outline, kind of. I think. Let's turn it off. This defaults. Billboard. What the fuck is that? What? Oh, is this one of those objects that constantly face you? Oh, it's very confusing to control this right now. Yeah, okay, it's one of those. Weird how it's not more consistent. If I have to oh, let me restart it. Add the keep scale thing. I don't entirely know what that means. That's really weird though. Why billboard? Huh? You press the wrong button. Particle billboard. I say this is like actually face the camera head on all times. Nope, it's not. What the hell's the difference? These ones I can do stuff like this with. I really need to fix my movement. Refraction. What does this do? What? Distortion is purely based on light from behind the object. So if I were to use a glass, I would some sort of glass texture, I'd use that. Scattering height. Clear coat. As a secondary transparency pass the lighting circulation, resulting in an increased specular blob. Have a clear layer on them. Could be either glossy or rough. Not even still, try to see if I can even see the glossy coat I gave it. I don't see anything. Maybe it's, I don't know what it is. Well, honestly, absolutely no fucking idea. What is it? Be like a shiny thing? I don't know. I wish I could figure out how to turn this into a mirror. But I have absolutely no experience nor idea how to do that. Just a real fucked this surface. I thought I could do that with a metallic. So we fucked around with that before, and I came to when we were doing 3D modeling stuff. Killer. Okay, let me grab these and let me just fuck around with these for a little bit, for a second. Okay, so wait, this one 3 then. There we go. That's not right. I want this thing. Well, this one would be number 4. Box. Do the 2x2. There we go. Oh yeah. Material, standard. Albedo. This one. Where's it? Oh, it's Albedo, sorry. And this one will be green. A little bit of green blue here. Do that Twitch green. What about this? Transparency. A scissor. Oh, that's right. These don't have boxes yet. Oh, let me fix that. Hold on. Uh, I don't know how any of that works. Yeah. Let's do use collision. Use collision. Collision. There we go. Come on now. Oh, man. Right. Oh yeah. Alright. I need to actually fix these fucking controls. Because every time I move, if I hit left, I go left, right, up, down, all that stuff. But it's not has nothing to do with where I'm facing. If I'm looking like behind me, if I hit W, I start going backwards. If you get what I'm saying.
Really moving in the direction that we're facing. This is an easy fix in the code. Right now, when we set the direction of our movement, we are setting it to where the character body is facing. Instead, we need to set it to where the head is facing, since that's the component that's looking left.
Oh my gosh, that's infinitely better. Oh, I can finally actually move properly now. Yay. My 3D platformer, let's go. I did it, yay. Press the wrong F key to close out of that.
Left and right for us. Nice. Now let's juice this game up. The first thing that we're going to add is head bob that will help us imitate the character's footsteps by moving the camera up and down. Maybe something like this. Can you guess which mathematical function we can use? That's right, the function of my emotional well-being while I was waiting for Godot 4 to release. I can't believe it's here. Or the lesser known sine wave. To implement this, we are going to need a couple of variables and constants. First is bob frequency, which will affect how often our footsteps happen. Second, bob.
Boy, we're getting in a fucking sideways. Oh, baby. All right. Free. Bob getting his freak
will
on.
affect how far up and down. Down our camera will go, and finally we will need a variable that we will pass to the sine function that will determine how far along the sine. We need a variable that we will pass to the sine function that will determine how far along the sine wave we are at any given moment. We're going to increment this variable during every tick of the physics process by multiplying a couple of things that affect our head bob. First, we want to account for delta, or how much time has passed since last tick. We will multiply this by the speed of our character, since we want to head bob more often when we're running. And finally, we want to make sure that we're only bobbing when we're on the floor. And
Okay.
we're going to increment this variable during every tick of the physics process by multiplying a couple of things that affect our head bob. First, we
It's
want to account
multiplication,
for
not addition. So del.
delta, or how much time has passed since last tick. We will multiply this by the speed of our character, since we want to head bob more often when we're running. And finally, we want to make sure that we're only bobbing when we're on the floor and walking, rather than jumping or falling. So we will multiply the result by the isOnFloor function, which converted to a float will either
Times float.
return 1 or 0. We can then assign the position of the camera to
Let's see. Where did that transform?
the result of the headbob function that we will pass the tbob variable to. Let's code this function real quick.
Origin.
It will return a vector3 variable that we are setting the camera position to within the physics process. Initially, this vector3 is
Okay. Vector. Sorry. Variable position. equal to dot 0 turn
Is going to be a 0 vector, but we are going to assign its y coordinate to the sine of t bob times bob frequency, and then multiply that by the bob amplitude. So now instead of going from negative
okie dokie. I'm gonna just pretend I understood any of that. Times
1 to 1 like sine, it will go from negative amplitude to amplitude. The result is a pretty good head bob, but if you're looking for a bit more realism, we can also add a horizontal component to this, since our head is also moving left and right when we're walking. This time
we'll worry about that in a second. I should make sure this even works to begin with. This does fucking nothing. Well, shit.
We're going to assign the position x component to the cosine of time, or t-bob, times bob frequency divided by 2. Still keeping up? Multiply this by bob amplitude as well.
Sure, dude. Sure. Okay. Alright, why am I so bad at typing stuff?
Wow, I think this will look way better for a lot of
This will like. Looking for. Okay. Evolve. Shit. Where'd it go? What? What's over here? Side by side of this. God damn it, stop doing that. There we go. Evolve multiplied equal. Oh, that's actually plus equal. Times velocity dot length is on 4. Camera dot transform origin equals head bob. Heat bob. Okay, but head bob. Time float. Position equals initial camera position. Okay. Initial vector this as vector 3. Got it. Okay. Come on now. Okay, so I just had to fix that part, I guess. So let me do this. I need to actually change this. So this is a plus and not a times. Oh, it works now. Holy shit. Is there a way? I wonder if there's a way I can set it to 0. Like once if I stop moving, it'll like reset it. Like smoothly reset it, not just snap it. Maybe there could be some sort of tweening thing I can do or something that slowly sets it back to its value, I guess. I don't know. Or maybe not even tweening, but some other function entirely. Maybe. Possibly. What's that? What's that? Ooh. Yeah, physics destruction. Hell yeah. But didn't I see something like that in here? I sworn. Fully destructible environments, that's what it was. I saw that. Oh, man. Oh, goodness gracious. Whew. Hmm.
Of games. Now let's add sprinting to make sure that our Bob looks good at different player speeds.
To do that, we'll change what we set our character velocity to in this code block. Since we now want our speed to depend on whether we pressed shift or not, it has to be a variable. So let's create
Damn it. There we go. So, yeah.
a speed variable and change our speed constant name to walk speed, as well as create a new constant
Got it. Oh, that's...
called sprint speed back in the physics proc speed, as well as create a new constant called sprint speed.
Right.
Back in the physics process, we will run a check on whether the player has pressed shift or not, and then set our speed variable to either
So your jump velocity, it was underneath that. What else yet? If is action pressed, that's speed is equal to else speed is equal to what speed? So we're gonna need to make another input map sprint. Was there we go. And bam. Yeah.
Their sprint speed or walk speed. With that all together, we can now run like the wind in our game. But let's look closer at some other mechanics. Specifically, there's an issue with the jump where we can stop immediately while in the air if we let go of the movement button. So let's fix that by adding a little bit of inertia to the game. We're going to do this by only giving the player full control of the horizontal movement when they are on the floor. When they are in the air, we are instead going to interpolate towards the desired velocity, only giving the player full control of the horizontal movement when they are on the floor. When they are in the air, we are instead going to interpolate towards the desired velocity using the lerp function, which changes our speed incrementally. This function takes three variables. In this case, it's our initial velocity, then our target velocity, and the final one is the decimal
velocity, direction. Times speed. Delta. Times 2.0.
percentage of the distance between the two variables that we want to cover in each step. Since our delta variable is usually around 0.05, multiplying it by 2 would make our current velocity move toward the target velocity by
What?
multiplying it by 2 would make our current velocity move toward the target velocity by 10% each tick. Now when we let go of the movement button,
Expression
midair, we will
as
just stop right there. You can play around with this value to figure out how much control you want while you're airborne, but I eventually settled on delta times 3. Another thing we can do is fix that running stop mechanic that wasn't quite times 3. How much control you want while you're airborne, but I eventually set
X, Z, direction X. Oh, my bad. Pause it. I gotta do this. Hold on. Ah. Just go. Okay, alright. Ignore all that. Alright.
Settled on delta times 3. Another thing we can do is fix that running
Hold on, what?
right there. You can play around with this value to figure out how much control you want while you're air.
And I want something ridiculous to happen. Oh my oh, that's awesome. Just woof. Gosh. Holy shit, what was that about? Woo! Situate between these two. Holy shit, I just started bouncing. Alright, let me do 110. Not too bad. Huh, not that bad. What is the breaking point of this? 2? 200 is big bad. After a certain point, it just starts breaking. What the fuck was that? What? What? Why is it vibrating like that? Well, I'm getting close to something breaking. What the fuck? Whoa! Well, that's definitely breaking something. That's such an awesome effect. Hold on. Dude, that'd be awesome for like a game mechanic or something. Just whoosh. Oh my gosh. That's insanity. I love this. Whoosh. 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 Dude, if I could figure out what's causing that, like, enable that as like a shader thing, that'd be so awesome fucking ability. Like, that's an awesome effect for like a teleportation thing. Just whoosh. It's so cool. Whoosh. Whoosh. You side chat, but whoosh. I just don't know exactly what's happening. But something is breaking big time. I love it. Walking around with it, seeing how it feels overall. Honestly, pretty good.
But I eventually settled on Delta ×3. Another thing we can do is
Like
fix
10
that running
personally.
stop mechanic that wasn't quite working in the character template. Just ramp up a little how fast we come to a stop here, and bam, inertia done. There's one last thing I want to do to choose, and bam, inertia template.
If perfect.
Just ramp up a little how fast we come to a stop here, and bam, inertia done. There's one last thing I want to do to juice this character controller up, and that's changing the camera field of view depending on character speed.
For this, we're going to need two constants. The base FOV, which you could change to a variable if the player can set the FOV in your game, as well as FOV change, which will multiply by our speed and add to our base FOV. In the physics process, we will be setting a local target FOV variable to this equation, which is base FOV plus FOV change
Hold on.
multiplied
What?
by velocity clamp. The reason why we want to clamp our velocity is to make sure that our
Oh, shit. What? There we go.
our
Perfect.
FOV doesn't go to the physics process, we will be set if the player can set
Oh yeah, sorry. No, wait. There we go. Sorry about that. Constant base. Sorry, I'm fucking losing it right now. Constant base. base. U equal to. I need to figure out what's causing that end thing to happen.
Set the FOV in your game, as well as FOV change, which will multiply
We change it goes.
by our speed and add to our base FOV. In the physics process, we will be setting a local target FOV variable to this equation, which is base FOV plus FOV change multiplied by velocity. Velocity clamp. The reason why we want to clamp our velocity is to make sure that our FOV doesn't go too crazy when we're falling when our velocity reaches super high numbers. So let's create a velocity clamped variable which will set to the result of the built-in clamp. Clamp function and restrict it to the minimum of 0.5 so that we don't change the FOV. Function and restrict it to the minimum of 0.5 so that we don't change the FOV when the velocity is super low, and a maximum of running speed times 2. After that, we'll use our favorite lerp function to set the camera FOV smoothly every tick of the physics process. Again, the first parameter is the original value, the second is the target value, and the third is the decimal percentage distance that we want to cover.
Box. Okay. Times.
And with that, our character controller is complete. The link to the GitHub
That's not right at all. Is that because I just set it to a higher thing? Oh no, that's just perma broken. Fuck! Come on! I hate it when it fucking does that shit. I don't even know how to stop it from doing that. Oh man, now I gotta figure out what is causing the problem here. Damn
The
it, dude.
project will be in the description so you can start where I left off. I might make a second part for this controller if you guys want me to add any specific features to this and if there's enough interest. If the video was helpful, drop a like and let me know what you think. Welcome back to the channel. Today we'll be doing a Godot level design tutorial. Hello controller.
Around here somewhere.
Variable which we'll set to the result of the built-in clam function and restrict it to the minimum of 0.5 so that we don't change the FOV when the velocity is super low, and a maximum of running speed times 2. After that, we'll use our favorite lerp function to set the camera FOV smoothly every tick of the physics process. Again, the first parameter is the original value, the second is the target value, and the third is the decimal percentage distance that we want to cover. And with that, our
Yeah, let's see. Where'd we go wrong here? Yeah, that's right. So 0.5. Fuck. ASP of the lerp camera.fov target FOV delta times 2 clamp velocity dot length speed. Damn. Oh, let's see if anyone's got a fix. One, two. Uh. Do that. I'll do 1.3. I don't know. I don't know what's happening. I'm just using somebody else's code. Yeah, I don't know what the fuck this is or how to fix this. Also, what the fuck? Hold on. What's happening with that too? Curious. What happens when I do this? It's not even doing it while I'm sprinting either, so it's not even a sprint speed thing. What the fuck? New game idea. Make you nauseous while you're trying platform simulator. Yeah, I don't know. I don't know what to do about that. Change to fucking 80 or something. What the fuck is happening? God, it's so annoying because I don't know what the fuck. I don't know what's going on. To be fair, I'm not even using my own code, but still. Alright. Fuck it. I don't know what to do with this. Only thing they can do is just remove the field of view thing entirely. Yeah, it was working fine outside this, but once I started getting out of this, it broke. Again, it's another out of date fucking tutorial, so can't expect it to be perfect. But yeah. Oh man. Whatever. I'll deal with that later. Or well, rather I'll just do something else instead, I guess. I'll move on to the next. I'll remove the FOV stuff and then move on to the next part of the tutorial. So I guess that'll be it for me for tonight. Sorry, this wasn't a great stream, I'll be honest. Kind of quiet, confused, didn't know what to do. These past couple have kind of been that way, honestly. Hopefully we can get some more flow going on. We'll see though. Yeah, until other than that, that's all I got for you tonight, everybody. So yeah. Good night, everybody. Bye bye. Bye.